Thank you for joining us during lunch. Appreciate it. As you said, I'm Kevin Feely. I've been in application security for about 10 years. Most of that time has been spent focused on DevSecOps, largely before it was called that. We just called it security automation or just security. This is my 5th time at LASCON, which I'm excited about. Food is always great. It's a great crowd. So I appreciate being welcome back here again. Thank you. Josh and I both come from Ernst & Young, who's relatively new in this space. We previously both worked at Aspect Security, so I was there for all of those 10 years. Aspect was acquired at the end of last year, early this year, by Ernst & Young to take over the application security consulting work that they do. So, Josh?
See if I can not make a lot of noise with this mic. Yeah, so I'm Josh Wallace. I've been in the consulting world for about 3 years now. Prior to that, I did development and application security in the electric and gas space. I've worked with Kevin in consulting for, like I said, about the last 3 years now. And, I think what he said is, pretty powerful, in a presentation like this, right? Because I think we're probably all pretty familiar with Ernst & Young. We probably think of them as, right, one of the big four, consulting, and, we think of accounting, when we think of Ernst & Young. But, just the fact that an organization, the size of Ernst & Young, took the interest in a little 50-person, application security company and purchased them, right, so they could increase their capabilities in that space is, I think that says a lot. And I think we're seeing that in a lot of the application security, kind of boutique firms that are out there today.
So we're going to talk about DevSecOps today. If you've been in this space for more than a day, you've read any sort of article, you've talked to anyone about DevSecOps, the first thing you always need to do is baseline as what are we talking about? Everyone defines DevOps, DevSecOps very differently. So we're here going to align to a particular definition. This comes from Jez Humble, one of the co-authors of the DevOps Handbook. It's called the COMS framework, which includes culture, automation, lean, measurement, sharing. So when we talk about culture, we're talking about how people interact, how they work together, how they get their work done. When we talk about automation, we're talking about how we take the components of what we do that is error-prone or that is not easily repeatable, and using machines to make it less error-prone and more repeatable. Lean is all about being really efficient, limiting work in progress, using small batch sizes. Measurement is important because most of our world is very subjective to us. Are we doing a good job at something or are we not? The more we can measure, the better, the more objective we can be, the more aligned we can all be together on the same page. And sharing is all about Care Bears and unicorns and making sure that we're leveraging things that other people have done in the past to do things better together. So this is DevOps, and when we talk about DevSecOps, we're really talking about the same thing. And this is a really important point, I think, in that security in a DevOps world needs to align to DevOps. So, think about the organizations you work for. How many people are on security teams here? It's most of the group. So when you look at this framework and you think about what DevOps is, do you think that your security organizations align to this framework? That you think about things in terms of how are development and operations working, how we can share more with them, how they can share more with us, how we can help them automate and they can help us automate, how we can have a culture of collaboration with them. Does anyone feel that way? Yes? So you're like, a little bit, yeah? For the most part, that's not what I see in the industry. And Josh will talk a little bit about that, but I think we're still very much in this world where we want to be in DevSecOps, but there's a lot that's holding us back from a security organization perspective. And we're not taking that step. It's really DevOps, and security is sort of siloed off, doing the traditional thing. And we've got maybe a foot in the DevOps world. I think we need to move a bit further.
And I think all of that foot is into automation.
Largely.
Especially in the security space. All right, so where's application security today? I'm going to move over here so I can see the screen a bit better. Financial service organizations are doing pretty well, right? They're kind of the huge outlier as far as what we see within our clients. For a number of reasons, right? Your regulations have applied to financial services for a lot longer than it has in the other space, and really they've been doing AppSec for the longest. You know, a lot of our clients in this space have been doing application security for, 10, 15 years at this point, whereas a lot of other types of organizations just haven't been doing it quite as long. That being said, other sectors are getting better, right? They're starting to do it. It's they're still kind of in the early phases, but it's happening. But the problem is a lot of that is driven by incidents. Really, I think when we think about a lot of organizations that are doing AppSec and doing it well, even those that have been doing it for a long time, where because of incidents, right? Some companies come to mind to all of us. I'm sure I won't throw any of them under the bus. But as we mature and as we're getting better, we're spending more time waiting on these application security activities. I'm sure somebody in your organization has got the idea to start doing static analysis or dynamic analysis. Then you implement these tools, and then you realize that it takes 3 days for your dynamic analysis scan to run. Then you say, holy cow, I need to do a complete deployment in 1 day. So how does this tool fit into my pipeline? Oh, and now we have 20 more applications that are under the scope of this service, and it just doesn't work well. And we're just spending more and more time waiting for these activities to complete. And our existing processes and workflows, they don't really scale well. All right, when we look at our clients that have a very high level of maturity in application security, a lot of the reason that they have a high level of maturity is because they're spending a tremendous amount of time on these activities. I have one client who's very mature, when it comes to static analysis. However, it takes them anywhere from 2 to 7 weeks, to actually consume the results of a scan and perform the triage and then get that information sent to Archer for the developers to consume. So if it's taking you 7 weeks just to do static analysis for one application, right, how can you deploy quickly? And right, the answer is you can't. You have to change those processes. But to further compound the problem, how do you do that while keeping that same level of maturity? And that's very difficult. Next slide. So DevSecOps today, compared to AppSec, AppSec's not even in the race. DevSecOps is moving quick. We're deploying code quickly. We have a lot of new tools, a lot of new technologies, and it's a wild west or a playground of just lots of different things, right? A lot of people I've talked to who work in DevOps, that's part of the appeal, is it's kind of this organized chaos, and they're constantly doing different things. When we start talking about AppSec, it's right. What do we think of with AppSec, right? We think of static analysis and dynamic analysis. And these tools have been relatively unchanged since they were introduced 20 years ago. And there's been very few innovations ever since then. So, and you kind of like the little pictures here, right? I'm from Kentucky. So, for the DevSecOps, that's why we had to have the horses, right? Kentucky Derby, fastest 2 minutes in sports. So, and we have the little lady here on the treadmill that's doing who knows what with VR, right? Maybe she's running a trail or something on her treadmill. So, all right. So the gaps in the current tools, and we've already touched on this a little bit, but pretty much all of the tools take a considerable amount of time to execute. It's common for dynamic analysis to take several days to complete for an application. We've got to do a lot of planning. If any of you have ever tried to run these tools straight out of the box, right, all of the vendors, hopefully none of you are in here, they tell you, hey, just, implement my tool, click a button, you've got application security, you've got all of your results. In reality, that's not how it works, right? A large number of the organizations I've helped, particularly in dynamic analysis, they've come to us for help, we've gone out there to help them out, and find out that their scans aren't even getting past the login page. So they're scanning, 1 page of a 100-page application. So, you've got to put a lot of thought and a lot of configuration into these tools, before you can actually use them well inside of your environment. Once you do get them configured and running correctly, you have a lot of problems with the results. And again, I'm sure a lot of you have seen this as well, right? If you take a static analysis scan, run it on one of your large applications, it comes back and it has 20,000 vulnerabilities in it. You know, so most places do one of a couple of things. They say, well, it's the developer's problem now. So they generate, you know, 3 700-page PDF reports and they throw it on the developer's desk and they tell them to figure it out themselves. That never works. Right? The other approach is you spend a tremendous amount of time triaging the results of that to get down to the real issues, right? And that's where the 2 to 7 weeks comes into play. Again, just to beat a dead horse, these tools are slow to evolve. You know, a lot of new technologies and frameworks aren't supported well by any of these tools. You know, there's one very popular tool that just started supporting Visual Studio 2015 earlier this year, right? We're almost into 2019. You know, and try using some of these fun technologies that we're starting to use more in the DevOps world, you know, Go, Rust, Kotlin, you know, et cetera. Virtually none of these tools actually support those technologies. And the same can be said for about a lot of older technologies. You know, off the top of my head, I'm pretty sure there's only one static analysis tool that supports COBOL, for example. So there's gaps on both ends.
So obviously this is a problem, right? Especially in this DevOps world that's moving very quickly. You have lots of new technologies, new languages, frameworks every day. So I just did a Google search to find out, you know, if I want to learn a new programming language, what should I learn today? And these are the results from Google. And 6 of the 8 languages listed here were on the previous slide as not well supported by current tooling, right? So this is a huge gap that we have today. And we experience this every day when we talk to our clients. They say, well, we have REST services. What tool should we use? Or you know, we have single page applications. What tool should we use? We're using Node.js. What tool should we use? And the answer is none of them, right? And that's not, it's an industry problem. It's not a vendor problem. As a whole, we're not doing a good job of innovating and coming up with new solutions for securing or understanding the security posture of applications we're writing using new technologies. The development and operations world is just moving a whole lot faster. The security world used to be okay 20 years ago. We innovated with static analysis and dynamic analysis, and we've sort of been clinging to that for a long time. So it's time to innovate some more. The biggest problem here is that we have this problem today, but if a college graduate or high school kid or a 3rd grader at this point goes out and tries and does the same Google search to figure out where they should focus their efforts, right, for their career path, they're going to go and learn these languages. And so even though we have a gap today in organizations where these applications are being developed, but it's only going to continue to grow because these languages that Google is recommending here, they're only going to grow in popularity, right? And so there's going to be a desire to use them more and more within enterprises, and the security teams are going to struggle to keep up. And just to drive it home, this DevOps thing is not going away. So it's expected in 5 years to be 3 times the market size that it is today, 25% compounded growth rate year over year. And obviously, there will be a zillion new tools. Probably during this talk, a zillion new tools have been created for DevOps. So in the next 5 years, there's a lot. How do we keep up with that? The gap is growing. That's the takeaway here. So we need to not only get in the race, but we need to accelerate. We need to start going faster than DevOps if we're going to catch up. So what's our solution? Well, the first thing is we need to align with DevOps. And so I do think that these 5, or if you count 6, if you count Prophet, 6 things align with DevOps. The first is we need to have a culture of experimentation. Right? The second, we're going to walk through these on the coming slides, so I'm not going to talk through them right now. Second is to automate your job. Third is leveraging standardization to help you scale. Everyone's always wondering, how do we scale security? Standardization is a huge first step that you can take. Measuring everything and shared responsibility. And if you're paying attention, you'll notice that if you look at the first letter of each of these words, it spells out comms, which is the same as acronym that we use to describe what DevOps is, right? So again, here, just want to drill home, we are aligning with DevOps, with the DevOps methodology. Security can't stand on its own in its own silo and say, how do we get better, without looking at what is DevOps doing and how are they getting better.
So I think a lot of you indicated that you're on security teams. So if you're not already doing DevSecOps, this is probably where we make a bunch of you cringe. So, right, a culture of experimentation, we think is very important. And when you look at, security engineers or application security engineers today, everything's very, I don't want to say calm because we're using that as an acronym, but everything's very calculated. Everything's a risk-based approach. And we want to eliminate risk. We want zero vulnerabilities to ever make it into production, even if it takes us 8 weeks to be able to do a release of an application, right? And everything's focused, on that risk and defense in depth and all the different activities that we do to eliminate that risk. And DevOps engineers essentially introduce risk, right? Again, it's lots of new tools, technologies, you're doing fun things, you're trying to release code or vulnerabilities into production even faster. And so it's a completely different mindset. And so, a DevSecOps engineer, has to be a balance of the two, right? And this is hard for somebody in AppSec. You have to be calculated, but at the same time, you have to be able to take risks. So does that mean you need to change the way that you're performing testing? Maybe you're only going to check for high severity vulnerabilities before moving to production. It can mean a lot of different things, right? But the key takeaway here is, you've got to practice a little bit of mad science and, accept a little bit of that risk, for the sake of innovation.
So the second is automating your job. And I want to be clear, I'm not saying to automate your job away. And there's this really powerful quote I made up. If you are able to automate your job, you'll never automate yourself out of a job, right? Because there's always going to be more to automate, especially in our industry. Huge skills gap, huge resource gap. Even if you automated everything that you and your whole team is doing today, you would still have enough for you and your whole team to keep your jobs and find more to do, right? So I did another search here on LinkedIn for a security engineer position because I was just curious, right? I know what our security positions look like. We're looking for people with pen testing experience and security architecture experience, maybe an ex-developer who can read code. But if you look at the job requirements for a security engineer at the companies that we would call the unicorns, like Amazon and Netflix and Etsy and Google, they're very different. Right? This requirement for just a security engineer, this isn't even like a senior security engineer. Their requirement says, expect to do software development. Right? That's part of your job description, software development work. And responsibilities include security tool development, not security tool use. We're not expecting you to take a commercial tool and run it. We're not looking for you to triage the results. We want you to understand what the security problems we're facing are today and innovate in our space by developing new tools. I think it's a very different viewpoint on how to handle security than most of us are taking today. And I think this is the future, and I think it needs to change, where our requirement, our expectations for someone in the security space is, yeah, you need to be able to read code, you need to be able to write code, but that's only a starting point. You need to be able to figure out how to solve the problems that our current tooling isn't solving, and then you need to work on solving them, right? You don't need to do it by yourself. You can be part of a team to solve problems, but you need to have a mindset of innovation. You need to be that mad scientist. And so again, going back to the previous slides, if we look at what our current tech stacks are and the current tooling, and we recognize that our current tooling does not support our current tech stacks, what are we doing about that? Well, at the rate that the commercial space is innovating and the rate that even the open source, right, the open source tools are focused on solving the problems that those open source developers are facing, which is great, but they're still focused on the tech stacks that those open source developers are using. And if those tech stacks are different than the tech stacks that your enterprise is using, the open source tools still aren't a fit. So you need to get your hands dirty and be willing to write your own tools. Let's identify what our problems are. Let's identify what our tech stacks are. And then think about what are our requirements for a tool that would adequately verify the security of our applications, right? As only one part of the SDLC is verification. But even looking at just that problem, what are our requirements for a tool to verify the security of our applications? That matches the throughput that we need. So we can write a tool or find an open source tool that will scan our applications as an example. But if that tool takes 3 hours to run, or even if it takes 20 minutes to run, but we want to be able to release every 5 seconds, then that's not the right tool for us. We need to develop something new. Right? So you have to understand what your requirements are. What does your DevOps team want to be? How fast do they want to move? Let's develop the right tooling to meet that.
And now we're going to say almost the opposite. So, like I said, DevOps is almost the Wild West, right? New languages, frameworks, tools, everything's coming out daily. And something that we see in a lot of our clients is, you work with an AppSec team, a DevOps team, whomever, but a common problem they all face is all of these teams have their own tech stacks. You'll work with the team that's developing this product, and they're using Java and Bamboo and Jira, and then you go work with this other team developing another product, and they're using SVN and Jenkins and who knows what else. And so you have this problem where each team is operating essentially on their own, kind of doing their own thing, and picked the tools that they felt were best for them at that particular point in time. And those teams are generally able to operate pretty efficiently, by using those tools on their team. However, when it comes to a security standpoint, and trying to inject application security activities into all of those different pipelines and tool chains, if you don't have any sort of consistency, that's incredibly difficult to do. So what the slide says here, what's easier to secure, 10 disparate systems or 10,000 identical ones. So if you can take, your tech stacks, your build platforms, your source code repositories, et cetera, and try to start standardizing those across your organization, then it becomes easier to inject those application security activities into those pipelines, ensure that your code is secure, right? And something, Kevin's going to talk about in a minute, a couple spoilers is, security test cases. And, if your tech stacks are standardized, then that's all the fewer, security test cases that you have to write in order to make sure that the security requirements are making their way into your applications.
So just to be clear, so we're not saying everything has to be uniform, right? You can have different sets of standards, different groups of tech stacks that your teams can choose from, different tool chains, but you have to understand what's out there. There still has to be some level of an approval process for something that's going to be used in a production way, so that, or at least, and by approval, it doesn't have to be formal necessarily, but the security team has to be aware. You have to have a risk assessment of understanding what the risks are, figure out how you mitigate those what controls need to be in place. So this is an example that we've been using for a few years for standard security architecture, right? So coming up with reference architectures for applications. So this is just an example that we put together for one of our clients where we say, okay, you want to build new applications. Here's a set of different types of reference architectures you can use that you can choose from that the security team has already blessed, that we've already looked at and said, here are the components in your architecture, and here are where the security controls need to be within that architecture. Now, if you give it a little more security attention, you can say not only these are the security controls that you need to have, but here are the ones that are already provided by the architecture. Here are the ones that just work out of the box, right? If you're going to use this is like a file server down here. If you want to use a file server as part of your architecture, you don't have to do anything from a security control perspective. The file server is already secure, the configuration works, you just connect to it. There are other parts of your architecture that are less secured out of the box. Things where we have security controls in place, we know they need to be there, and they're there, but you may need to do something to make them work. You may need to provide a configuration, right? Modify a configuration file or define what the roles are of your users, right? And then there are other cases where the security control needs to be here, but we don't provide it at all. Those are cases where the developers need to write their own security control from scratch. And that's a little dangerous, right? But now if you know this information, it gives you the ability to do your security activities more efficiently, right? So first, you've given developers a more efficient way to develop secure code, because now they know specifically the areas where they need to focus their attention on security, and you can give them specific guidance about how to do that. But now on the security verification side, we now have a streamlined approach too, because These green boxes, these green areas, where we say you need to have a security control and it's provided out of the box it works, we don't need to verify that at all. Maybe you have some lightweight end-to-end test just to make sure everything's working in production, but otherwise, we know the developers don't have to worry about this. In other areas where you have security controls that exist but need to be configured, we don't have to check if the security control was built properly, we only have to check the configuration. Right? That in many cases can be easily automated. And the last is where developers have to write their own security control from scratch. That's where we really need to pay attention. So when we look at this from a security activities perspective, we do security architecture reviews for some of our clients, and they can be super efficient because developers can come to the table with the reference architecture, with their actual architecture that's built off of it, and we can compare them and say, what have you changed in this architecture? And then we only need to review those components. We don't need to review the whole architecture. And from a more tactical, lower level security verification perspective, we can say, security as code, right? We can write specific test cases to only test the things that developers have modified, right? So we can be very focused in our security testing. The last thing is sort of an added benefit is this improves the conversation with developers about security. It gets them involved earlier on about what the security controls are, where they need to be and what they need to look like. And so you can have a standard taxonomy to talk to them, right? Do you call it access control or authorization, right? There can be a breakdown in language pretty early on when you're talking about an access control issue and the tool they're using or the report they're seeing says authorization. And they're like, are these two different findings? Is this the same thing? How do I handle this? So if you have the same language, it makes things a lot easier too.
So metrics. Metrics are fun, metrics are hard. So when we're talking DevSecOps though, the important thing here is to collect as much data as you can from everywhere, right? It's, I think organizations struggle with where to start with metrics and they have a lot of conversations about it. And it's hard to get anywhere, right? Somebody comes up and they says, okay, well, I think these 4 metrics are important. And they take that to the next level. They say, no, we don't care about those metrics. We want these 4 different ones. And in the end, you spend a year talking about it and you end up with absolutely 0 metrics and nobody really knows what they're looking for. And all that time, you're just ad hoc, trying to grab that data from all of these systems and hack it together in some way that makes sense. So, you don't know what your metrics are going to look like a day from now, a month from now, a year from now. Just collect it all. Put it somewhere. Right? We have all kinds of log management systems, right? We have some SIM vendors out there in the showroom, that are all very good at taking all of this type of data and putting it into one location for you. So, but the key point here is just because you don't know that you need it right now, you might need it tomorrow or a year from now. So if you're already collecting that information, it's going to be a whole lot easier for you to put it together in a useful way when you know what it is that you want. And as far as what it is that you want, like I would advocate that you start somewhere. Take some metrics that you think are interesting and useful for you or your organization or even just your team, and just put them together and start sharing them with the team. Right? Create a dashboard or something like that. Because once other people start seeing those dashboards that you create and those metrics, it becomes a whole lot easier for them to conceive what it is that they want, right? And what's useful for them. And what's useful for each person is going to be different, right? What you want to see on a security team is going to be different than what your project managers want to see, which is completely different from what your CISOs want to see. So a single pane of glass dashboard, for each of those different teams, it can go a long way. And also once you have more of that data, you can start correlating it to find additional patterns. A very rudimentary example is, maybe your static analysis or dynamic analysis tool found, a SQL injection vulnerability in an application. But then, your IPS, actually blocked a SQL injection attack in production, right? By having that data and correlating it together, you can see not only that you have a vulnerability in your source code, but that it's also in production and that malicious users are actively attacking that vulnerability out there. Next slide. So, I just wanted to throw a couple of sample metrics at you. Again, right, just pick a starting point and start with something that's useful for you, right? And this is where a lot of organizations are today, right? Things like, number of findings per security category, right? So we have found 700 cross-site scripting vulnerabilities this year. We spend an average of 2 weeks triaging the vulnerabilities of each application. But where we want to get to with all of this extra data is to just take it to the nth level, right? So in the future there we have, the average number of DOM-based cross-site scripting vulnerability released on a Thursday before a holiday by Kevin right here, when the moon phase is waning, right? And it's going to be a really big number. But the point is, we need data to get there. And if somebody decides tomorrow that that's a metric that they want, you're going to scramble to get that data, right? You don't know where that data exists, if it's currently being logged today. And if it's not being logged today, that information's probably not all that relevant, right? We need history. We need trending, right? Metrics become more valuable over time as you have that historical data. So the longer that you're collecting it, even if you're not having metrics with it today, right? Start collecting it, because in a year when you want that metric, you're going to have the historical data, and then it's instantly valuable.
This links back to the DevOps methodology of log everything, right? So if you log it now, you never know if it will be useful in the future. I can definitely see metrics like this bottom one happening in the future, right? Like predictive analytics to know, how do we know when we need to do security activities? Right now we're saying, well, you need to do them on every release, or you need to do them every 6 months, or you need to do them every 4,000 lines of code that have changed. It's arbitrary metrics that really aren't based in anything. It's subjective, right? But once we start collecting more data and we understand when issues or vulnerabilities are actually introduced, under what circumstances, by which teams, with which architectures, by which individuals, right? We could still have a blameless society. You don't have to blame me when I introduce these vulnerabilities. It's just data. It allows you to do your job better and make sure your applications are secure. It can also help me to do better, and maybe I can not have a drink on every Thursday before a holiday, right? And less vulnerabilities.
All right, so what we're seeing across a lot of our clients is that they're organizing their teams around products, as opposed to traditional teams, right? Traditionally we have a development team, a security team, an AppSec team, maybe a PMO, et cetera, right? But as we're moving more into DevSecOps, we're seeing this shared responsibility, and we're organizing as these product teams. So if we're going to release a new product next year, we're going to create a new product team that's going to have 2 developers on it, an application security person, et cetera, et cetera. And that's something that seems to be pretty rudimentary DevOps, right? This is just an observation, and we're seeing a lot of organizations do this today. Same thing with application security champions. As we start having more and more of these product teams, application security engineers are in a lot of demand right now. There's not enough of us, and we're spread pretty thin. And so, application security champion programs are a great way to be able to scale that out, to where you can have one security champion that's aligned with multiple of these product teams, to be sure that the application security activities are happening, in all of these different products. And it's as we're sharing responsibility, sharing development and writing code, as Kevin mentioned, right? Part of everybody's role and responsibility essentially becomes writing code. So it's not just the developers on your team that are writing code anymore. Your security engineers are writing code to do test cases. Your operational engineers are writing vagrant scripts, or infrastructure as code, and all of this code is being shared amongst the product team, right? So again, the silos are getting broke down. It doesn't matter if your infrastructure team is writing all this super cool infrastructure as code if they don't share it with the security team, right? Because the security team needs that in order to be able to run their security test, because maybe maybe they need to take the application and deploy it in a runnable state so that they can run dynamic analysis as a test case on the application before going to production. And if you don't have infrastructure as code, then quite simply you can't write those test cases.
So we mentioned test cases a few times, right? This is about sharing responsibility where developers start to take more ownership for security. But they're not enabled today to do that on their own. They really need help from the security teams to understand what test cases to write, how to write them. Security team needs to be involved to make sure that they have the right level of depth in their security test cases, that they have the right level of coverage. I want to be clear here to use the term test cases or security as code. There's a lot of talk, I feel like, in the AppSec industry about security unit tests. And I'm challenged by that because I feel like there's a disconnect between the security and development and quality who are writing tests, right? So there's all different types of tests. There's unit tests, there's integration tests, there's end-to-end tests, there's regression tests, there's other tests that I'm not aware of. And we're not doing a good job, I think, of bridging the gap to those teams when we come in and only talk about unit tests. In my experience, there's not a whole lot of security unit tests you can actually write, right? Most security tests that are powerful, that have the right level of coverage, end up being more dynamic tests, which end up being in the integration test or end-to-end environment, right? They run similar to a dynamic analysis test. Otherwise, you end up, in many cases, sort of recreating a static analysis tool as at the unit test level, right? And so just from a language and taxonomy perspective, I think we need to be aware that as we try to bridge the gap and get into this DevSecOps space, we need to do a better job of understanding what those teams do and the language that they use and the differences, the nuances between different types of tests. So the problem here, is, as we've talked about, is that current tooling is not fast enough. It's not scalable. The tools are written generically. They don't necessarily support your tech stacks. So we need to write new tools. We know that. You can write tools at different levels. You can write global tools that will test all of your applications in some capacity once you understand your tech stacks. You can write tailored tools that test specific tech stacks or specific applications. That's more what we're talking about here, where you have a test that will run within the development environment, usually within the integration environment, that will test a specific function of a specific application. And it really works because it understands the specific tech stack underneath. There's a lot to do in this space. I'm going to give you an example in a second, which will hopefully solidify things. But there's a lot more we have to do in this space. Let me jump ahead to the example actually, and then I'll come back here. So here's an example of a test case, just a fairly generic test case that will test for your cache control header, right? Make sure that your cache control header meets whatever your policy is. In this case, we want to check that the cache control header is set to no cache, no store, max age 0, and must revalidate, right? That's what our policy is. That's what our leading practice is, right? And this can run just alongside all of the other developer tests that they've written, functional tests. So the top part here, if you're not familiar with the syntax, the top part is written in Cucumber, which is a behavior-driven development framework for writing test cases. You can see it's basically English. Most people within an organization should be able to read that and understand roughly what the test is doing. And then the bottom is code that's actually executed based on running the test case at the top. So there will be additional code that's not here that will, as it says, given the application and integration environment, should spin up a new application in the integration environment. When user ABC is authenticated, that will send an HTTP request to log in a user, get a session token back, and a GET request is made to endpoint account data. We'll send a GET request using the session token that we've already gotten from our authentication step. Then the response should have status code 200. So we'll check the response and make sure that the status code is right. And then the most important part is, and the response should have header cache control. So checks that the cache control header is there and it's set to this value. And that's what the code on the bottom does. So this is just an example of the type of test we're talking about. Pretty easy to write. And really the best part about this test is that you could check for any header with this test, right? So we're checking for cache control here, but if you wanted to check for CSRF headers or any other type of header, you can easily just duplicate this top part. You don't even have to rewrite the code on the bottom, right? This is all parameterized. You just take the top, copy it, paste it, and change the last line to some other type of header, and you're good. And so the security teams can write this code, write this, provide it to the development teams, who can then use it. And as they start to understand security better, they can write new test cases. As you have new security requirements, you can say, here's the template you should use for all of your applications to test those requirements. So we found this to be pretty successful. But there are some challenges here. First is that this doesn't support everything, right? So like that test case sends an HTTP request. It's based on HTTP. If you're using some other protocol, you need to figure out how to test that, like for your toaster. I don't know how to test your toaster. That's a new area that we're going to have to figure out. Legacy applications can be challenging, right? Mobile applications are also challenging. Mobile applications are largely manually tested today. We need to figure out how to do better automating mobile testing. Other security categories. Testing headers, transparent, very easy. As you can see, that wasn't difficult to come up with. It wasn't difficult to implement. But there are other security categories that we haven't figured out how to test. It may not be possible in some cases, but we need to do more mad scientist work to figure out what is possible and what's not, and then implement whatever is possible. And then rolling it out is very difficult, right? So if I'm going to give this to a developer and say, write these tests or write more tests, they're only going to do that, they're only going to be willing to and able to do it if they already have a testing culture where they're already writing functional tests, where they understand what a test is supposed to look like, how it's supposed to work, how often it's supposed to run, things like that, right? So there are requirements here. You also have to have the supporting infrastructure. So you could do this with a static server, a static test server that's up and running, but it works much better if you have these ephemeral servers that can spin up and down, and you can make sure that you're testing in a clean environment that mirrors production. You also have to have test accounts in most cases. We ran into a problem with one of our clients here where they had this great DevOps group and they have the infrastructure that spins up and spins down and they have everything linked in CI and we can run the tests, no problem. But their test accounts are shared between different development teams. And so we set up some access control tests using these, the same sort of model, and it worked on day one, right? Test to make sure that user has access to this resource, does not have access to this resource, worked perfectly. The next week, we run the test again, and we get a different result because a different development team changed the roles assigned to that user. And so if you don't have either static test accounts or a way to configure them dynamically, you run into some challenges here. And there are other prerequisites also, but the important thing to recognize is that these types of things are not necessarily things that the security team thinks about. You have to get into a different mindset and think about how would a tester do this? How would a developer do this? How would operations do this? And think about, to figure out those sorts of dependencies. So now, sort of bonus content. These are just some other things, I think, that are really important, sort of along the same lines. You want to talk a little bit, Josh, about it?
No, go ahead. Okay.
So similarly, infrastructure as code, right? So if you don't have infrastructure as code, then you probably don't have a repeatable environment. DevOps is really based on the fact that your test environment should mirror production. As security people, we understand that's very rarely the case, right? I mean, how often do you test that a certificate meets whatever your security requirements are, right? The TLS certificate, and it doesn't. It's a self-signed cert, or it's signed. It's not respected by your certificate authority. And then you bring it to the development teams, and they say, "Oh, that's not the cert we use in production." Well, it should be, right? It should at least meet the same criteria that you have in production, because otherwise we're getting false positives in development. We're wasting our time. We're wasting your time, and our testing we can't accurately test. So you need to have an environment in development and test that mirrors production. The other thing here is we share test environments. I don't really understand this. So like you have user acceptance test environments, you have staging environments, you have development environments. Where's the security test environment? Why don't we get environment to test in? When we want to do manual pen testing or run dynamic analysis, we have to go and talk to the development teams and say, can you set up a time when no one else is testing this environment and that it's stable and has this version of the release? We should be able to do that ourselves, right? And if we have infrastructure as code, if we can just go into their Git server and grab their configuration files and launch it ourselves, or talk to the operations team and say, give me an environment that looks like this, that's running this version of the application, just like the development team should be able to do, then we can have a stable, repeatable environment, and we can do our jobs a lot more efficiently. Similar with scalable ephemeral servers, right? Having a security test environment. Automated functional test suite, right? That would help us drive dynamic analysis with more repeatability, ensuring that we have coverage of all of the workflows. If you're using something like interactive analysis, similarly, then you need to, it's a prerequisite, right? It's also a prerequisite if you want to have your developers writing their own security test cases, as we talked about, right? So again, these are things that you may not be thinking about as a security group because they're not really something that's under your purview, right? This is someone else's responsibility. It's development or operations to make sure that these things happen from the DevOps side. But security needs to be involved in that conversation and say, here are the things we need to do our job better. System and process standardization, we talked about a little bit. This is really difficult. So if you start looking at how do you automate static analysis and continuous integration, it gets really tricky with which branch do I scan? I mean, that alone can be challenging. Do I scan a branch? Do I scan a tag? How do I know exactly what to scan and then who do I give those results to? Because developers may be creating multiple different branches.
That's why we just scan dev every time.
Yeah.
Right? Anybody hear that? Your dev branch just constantly gets scanned and you have a scan queue like 200 deep. I also like that you call out API definition files here, right? If any of you pen test and you ever have, a REST API in scope and, the organization doesn't give you the source code or their Swagger or something that gives you a definition of what those endpoints are, it's darn near impossible to test, right? So same thing in DevOps land, right? Those API definition files are incredibly important in order to be able to perform those security tests.
And then the last is just having a single reporting system, right? I think there's still a lot of PDFs being passed around, spreadsheets being passed around, or you get some new tool and that's got a new portal, a new console to use. You want developers to log in. It's too much, right? Developers have enough tools. The business risk side is enough. Everybody has enough portals to log into, enough places to get different data. You need to have one place that they can go and get the information they need to do their job. And integration with chat ops, ideally, right? Some way to get information easily, bite-sized information, right? Type to the bot, when was my last scan run? The bot tells you. So I don't even have to log into some other system. I've got the chat open. That's definitely growing in popularity too.
And we still have to be careful with how we do that, and we have to do it intelligently, right? Everybody right now wants to take all their security findings and put them in Jira, and make stories and defects out of them. Right, but if your scan has 60,000 findings and you dump 60,000 findings into Jira, that's not helping anybody. You're making the problem worse, than having a 700-page PDF. So we still need to be intelligent in how we, put that into a single system.
And the last is credential storage, and that could sometimes be in the realm of AppSec. Sometimes it's in a different security group, right? But we talk a little about why that's important. Having standard credentials, whether for automated testing or for custom automated testing or for dynamic analysis, or even just for your pen testers who want to be able to go and pen test without having to bother the development teams and have someone create new accounts and things like that. This is a long process, right? I mean, this is not something we're going to get to overnight or even in the next year, 2 years. This is an industry shift that I'm trying to talk about here. It's a difference in mindset in how we think about application security and how it relates to the other domains that we try to work with. So it's little by little. And I think overall, it's a changing culture and mindset. So if you look at how we do application security activities today, we take a particular approach, right? We take a risk-based approach. We try to understand our applications and what the structure is, and then we identify what the security activities are, and then we choose the tooling and we run the tooling. And we're all doing the same thing. And I guess what I'm saying is we need to rethink that. And so it's not a matter of how much time you can invest. You should invest the same amount of time you're investing today, unless you can invest more. But I think the approach needs to be different.
It's a challenge, right? And I think it's a challenge that every organization that wants to move faster is facing right now, and it's a large part of what we do. And I think it's, again, you got to change that risk-based approach a little bit. What's your security policy, right? Do you need to test for every vulnerability under the sun And if you do test for all of them, are you going to fix all of them? Or does your policy say, hey, no critical or high level vulnerabilities are going to make it to production, right? So then you can reduce your scan time, by limiting the number of patterns that you're testing for. Additionally, right, if you're organizing your applications by risk, so if you have an internally facing static brochureware application, you shouldn't be testing and triaging it the same way that you do your external consumer facing application that's actually transferring funds. And I think to Kevin's point too, as you start collecting more of these security test cases, you can reduce your reliance on what some of these tools are doing, right? So if you're using dynamic analysis to test for cross-site scripting right now, and that's just a fun one to pick on, it's right. The dynamic tool is going to go through, it's going to scan your app, it's going to take 2 days, it's going to find every request, it's going to beat the ever-loving hell out of it, with additional, payloads to try to find the vulnerability, and that's time-consuming. But if your security requirements say, hey, we're going to use OWASP SAPI to prevent cross-site scripting in our organization, you can write a test case very easily, to check for the presence and proper configuration of a SAPI. And then at that point, you can turn the pattern off in your additional tooling, and that's all the more time saved in your process.
I think that's the key point, though, is do you need to be running static analysis on all those applications all the time? What are you getting out of that? Are you getting the information you need, right? If you have, which most organizations don't, right, have very detailed security requirements that, offer you should be using these libraries to do these things in these situations, and developers are following those, then you're looking for anti-patterns, right? You're looking for where is that not the case. That's much easier to do than trying to scan your whole application. So if you can start with the security requirements and then try to standardize as much as possible, then that helps you figure out how do I test those things. That's the approach that I would like to take. It's very difficult, right? I think this is a big shift away from what the industry has done largely in the past. Yeah. Does that answer it? Okay. Anything else? I think we're probably out of time because the next group's probably here for someone else.